Well, we're looking at topics in analytic geometry here. So we're going to first start. Make sure you copy this into your notes. The general form of a line, slope-intercept form, point slope. And this we don't use very much, but you can use that. But sometimes you have to solve for these things before you can use that formula. So now let's talk about the inclination of a line. Now in analytic geometry, we're talking about an angle here. Now we've been finding the inclination before in just regular algebra 2 by finding the slope of a line. So let's work a few examples here. The slope in this case is 1. I'm going to call that m. But what I want is the angle. So I'm going to take the calculator and reset it. Second plus 7, 1, 2. Now I want that angle to be in degrees, so I'm going to check my mode, go down to radians, over to degrees, enter that, and I'm good. Now the way I find the angle is by finding the angle, let's call it theta, is the inverse tangent of m. So theta in this case is going to be the inverse tangent of 1. So using the calculator, I'm going to go second tangent 1, and I get 45 degrees. So the inclination in this case is going to be 45 degrees. Let's do the same thing over here. First I'm going to solve for y. So I get negative 3y equals negative 4x plus 2. Just by moving the 4x over. I divide by negative 3, and I get y equals 4/3 x minus 2/3. I don't care about that, that's the intercept, but I really just need the slope here, so m is equal to 4/3. Let's double check, make sure we got that right, move the 4x over, make it negative, divide by negative 3. We get a positive 4/3 minus 2/3. Let's put that in. Second inverse tangent, 4 divided by 3, and I get 53 degrees. Therefore the inclination is 53 degrees. Now let's do this one. I get 5y equals negative 4 x plus 2, divide everything by 5, and I get y equals negative 4/5 x plus 2/5. So I see that m is equal to negative 4 over 5. Okay, now let's put that in. Second inverse tangent, negative 4 divided by 5. And this time I get a negative angle. So I see that theta is negative 38.66 degrees. Now I need that to be a positive number. Now the corresponding angle for this is going to be in the second quadrant. Now this 38 degrees is a reference angle. So what I'll need to do now is this. Theta becomes 180 degrees minus 38.66 degrees. And let's see. That becomes a positive 141.34 degrees. So when I got this negative angle here, all I did is add 180 to it. And that gave me the angle I'm looking for. Now that's in the second quadrant there. Okay, that's pretty straightforward there. Let's talk about the angle between two lines. Now we're going to use this formula here. The tan of theta is the absolute value of m2 minus m1 divided by 1 plus the product of m1 and m2. Now m1 and m2 are the slopes of the line. So let's find an example here. Let me copy this over again just so we don't have to flip back and forth. The tan of theta is equal to the absolute value of m2 minus m1 divided by 1 plus the product of m1 and m2, and that's absolute value. Now let's double check that, make sure we got it right. M2, yeah, looks okay. So the first thing we're going to have to do is find the slopes here. So let's call m1, this is m1, let's rework this equation here, and we get negative y equals negative 3x plus 3. All we did is move the 3x over to the other side by subtracting. Now divide by negative 1, and we see that y is equal to a positive 3x minus 3. So m1 is equal to 3. Now let's find m2. So m2, we're going to rewrite this as 3y equals negative 4x plus 12. Now divide by 3. We get y equals negative 4/3 x plus 4. So m2 is going to be negative 4/3. Now I'm going to plug it into this equation here. Now this is the tangent of theta. I want the angle. So theta is going to be the inverse tangent of whatever I've got here. m2 minus m1 over 1 plus the product of m1, m2. So I'm going to find this first. And I'll put this in the calculator this way. Actually, I can put that in too. So let's just find absolute value. And now I am going to need to put, now let's use parenthesis. m2 is negative 4 divided by 3 minus 3 divided by 1 plus 3 times negative 4 divided by 3. Let's see what we get here. We got 1.444. So I need to find the inverse tangent of that. So second tangent, put the answer in, and I get 55.3. So theta is approximately 55.3 degrees. And that's going to be the angle between those two lines. So we got several steps here. First you're going to find the slope. Then you're going to plug it into this formula here. And then whatever comes out, you're going to use that in the inverse tangent key on the calculator to find that. Now let's work on finding the distance between a point and a line. Now we're going to use this formula here. So the first thing we have to do is make sure we have this in this form here. So this 10 needs to be moved over. And we'll write this as 3x plus 4y minus 10 equals 0. So ax plus by plus c equals 0. Now x in this case is going to be 2. So the distance is going to be the absolute value of a, which is 3, and x is 2. This is my x here, plus 4. My y is going to be 2 minus 10 divided by the square root of a squared. A is 3 and 3 squared is 9. B is 4, b squared is 16. So this is going to be the absolute value of 3 times 2, which is 6, plus 8 minus 10, and this is the square root of 25, which is 5. 6 plus 8 is 14, minus 10 is 4. So the distance between those two is going to be 4/5. Okay. Now, for example 4, finding the area of a triangle in the plane. Probably the simplest way to find this is using Heron's formula. Now, Heron's formula says that the area is the square root of S times S minus A times S minus B times S minus C, where S is going to be, what is S again? A plus B plus C divided by 2. Now A is going to be the distance. Let's call this side, well, let's follow convention. This is A, this is B, and this is C. So let's find A first. A is going to be the distance from B to C. So we're going to use the distance formula for that. So the distance for A is going to be the square root of, that's B to C, 5 minus 1 squared plus 3 minus a negative 6 becomes 3 plus 6 squared. So this becomes the square root of 5 minus 1 is 4. 4 squared is 16. 3 plus 6 is 9. 9 squared is 81. So this is the square root of 97. The distance for B, here's B over here, is from A to C. A to C. So that's going to be 5 minus a negative 4 becomes 5 plus 4 squared, and 3 minus 2 squared. Well, 5 plus 4 is 9. 9 squared is 81. 3 minus 2 is 1, and 1 squared is 1, so this is the square root of 82. And then the distance for C. Well, C is going to be from A to B, so this is going to be the square root of 1 minus a negative 4 becomes 1 plus 4 squared plus negative 6 minus 2 squared. This becomes 5 squared, 25. 8 squared is 64. This is the square root of 89. All those are radicals here, so now we're going to have to do this up here. Now S is going to be square root of 97 plus square root of 82 plus square root of 89, all divided by 2. Now this is going to be an ugly radical, so I'm just going to approximate these things, and I may as well start with that. So let's take the square root of 97. And I'm going to go to 1 decimal place so it doesn't get too unruly. 9.8. Now this is an approximation, so let's write it that way. Let's find the square root of 82 is 9.1, and the square root of 89 is approximately 9.4. So this is going to be approximately 9.8 plus 9.1 plus 9.4. Then we're going to divide that by 2. So this turns out to be approximately 14.15. So the area, again this is an approximation, is the square root of 14.15 times 14.15 minus 9.8 times 14.15 minus 9.1 14.15 minus 9.4. Now if we put all that in the calculator and take the square root, we should be okay. So 14.15 minus 9.8, 14.15 minus 9.1, 14.15 minus 9.4, and we need the square root of that, and we get 38.43 square units. And again, that's an approximation. Well, that's a little tedious, but you can get there. Okay, now we're going to talk about circles. Now, for a circle, you need two things. You need to know the radius and you need to know the center. Now, this is a general equation of a circle here. It's x minus h squared plus y minus k squared equals r squared, where the center is h and k. So let's do this one. X minus 0 squared plus y minus 0 squared equals r squared, so that's 4 squared. So this becomes x squared plus y squared equals 16. That's our equation. Let's do b then. We have x minus a negative 2 becomes x plus 2 squared plus y minus 3 squared equals 8 squared. So this becomes x plus 2 squared plus y minus 3 squared equals 64. Okay, that's my reminder that I'm out of time, so I'm going to stop here.